All right, so this is really Module 5, right? For all intents and purposes, if you're looking at the module, it's Module 5. But I'm going to give it a title. I typed this up separately. This is on Teams. If you want to click on Files and you click on PowerPoint Slides, this is a file, so it's not in the cloud. You don't have to request permissions or any of that kind of stuff, which we ran into with the website. So if you want the PowerPoint slides, they're there. They have some graphs in them. I'm going to remind you also on the YouTube channel, there is a review of every single chapter. Right? There's a review of the first chapter, which is only 10 minutes long. There's a review of this chapter, which is a lot longer because this chapter is huge. But we're going to go over a lot of very important foundational stuff today. So what I chose to call this was research methods. This is the literal methodology that psychologists use to get findings, to get results, right? Research methods. So I'm going to teach you several phrases today where you're going to see a lot of vocab on the screen. You don't have to write the definitions to the vocab words. I try to strategically type what they are and underline stuff so that you can kind of see, some examples. So I'm going to come up with as many examples as I can come up with, and hopefully that helps you. But I'm going to teach you a couple of phrases also that will be important for you to know. And so if you just kind of stay tuned for that. The first thing is this. And I think it was this class, but I know it was in other classes also. We discussed it's a common sort of joke or running argument between other scientific fields that psychology is the rat science or psychology is the science that's not a hard science. And some of that criticism is fair because you can't scientifically test everything in a lab that psychologists want to know. But some of that is not really fair criticism because there are a lot of things about the physical realm and the physical world, especially theoretical physics, that we can't really, other than mathematically quantifying, we can't scientifically test in a lab. It doesn't mean that we don't want to know. It doesn't mean that we don't want to test it, right? For instance, wormhole theory is nothing more than theory. Yeah, the math works, so in theory, wormholes are mathematically possible, assuming that the universe is binary code. Right? But that doesn't mean that it's a tangible thing that we can touch and that we can test in the lab and manipulate against the control group and gain a cause and effect answer. So here's the reason why I say that. It's not that theoretical physics is useless. Quite the opposite. Theoretical physics is very, very, very important for understanding space and time and the laws of the physical world and the universe, dark matter and things like that, string theory, time travel. My point is simple. Psychology is very similar. They are theoretical principles that we're trying to scientifically test and prove. And we talked about Socrates and this idea of, does the person have a soul? Do you have a mind? What is your personality? Your consciousness? Where is that? Right? Does it exist in your brainstem? Does it exist in your heart? Does it exist in cerebrospinal fluid? We know that when you die, you cease to be conscious, we think. No one's ever died and come back and explained it before, so we think. So there are a lot of concrete things that we believe are true but can't test. It's like the question on the last test that you took. Psychology is limited in its scope for evaluating biology. We know that you have a soul, but we can't prove it. We know that you have a personality, but we can't prove it, right? And so other questions like, are serial killers born or are they made? They're nurtured. Are they, does the body decompose, but the soul continues on in the afterlife? Is there reincarnation? Are you genetically the same as your parents in personality traits because of biology, or is that because of your nurture? So there are a lot of questions that psychologists want to know the answer to, but we just can't prove them. Doesn't mean they're not valid to test. So we have to be scientific in our approach to any psychological question. If it's nature versus nurture, we should want to scientifically find the answer. But we have to look at this from a Socratic standpoint. There are several biases that humans have. There's a lot of things psychological that are also, let's say, social or political. Right? For instance, our next score discussion is about racial injustice. Whether or not skin color is a barrier to upward mobility. Well, that's horrifying to even think about. But the fact of the matter is this, is that we, from a Socratic standpoint, should A, want to find the truth to that question, but B, we have to be willing to evaluate scientific empirical evidence as a mode of conclusion. So in other words, let me say it this way. If we can scientifically conclude that, let's say, for instance, our agenda, that's not the right word, our narrative is not scientifically backed, right? I believe that human beings are very much contributing to global warming and things like that. So I'm going to go on the record as saying that. But that's a good example. If science doesn't back up, if the data doesn't back up the narrative, we have to abandon the narrative. If the data doesn't back up the narrative of white privilege, we have to abandon that narrative. It's not to be insensitive. That's the point. This is what's beautiful about psychology and philosophy, is the idea that there are things that we're emotionally invested in that you should be emotionally invested in. But yet, logic is a separate thing. So you might emotionally say, I feel that this is the case. But logically speaking, you have to be willing to accept the fact that that may not actually be the case. So here's the first phrase I'm going to teach you. You've heard me say it before, but now I want you to write it down. And that is that observation is not evidence. Observation is not evidence. And here's what I mean by that. It's pretty simple. Sometimes things appear to be the case. We observe something and it looks like it's the case. Like in the case of racial injustice. Something may appear to be an abuse of a system. In the case of climate change, we might look, the ice particles are melting. I observe that to be evidential proof of global warming. Well, global warming isn't real because we observe that the ice caps are melting and that the polar bears are floating on ice. Global warming is real because the statistical data tells us that it is. And also because during the shutdown, places like Venice, Italy could see the bottom for the first time in centuries. Oh, maybe all those boat emissions coming out of it, right? So that shouldn't be a partisan issue, in my opinion, right? Whether or not we can take care of the environment shouldn't be a partisan issue, right? Even from an economic standpoint, you should want renewable energy just because it's free. You want to keep putting gas in your car, you want it to run on a solar panel, right? So it shouldn't be a partisan issue. It should be an empirically, scientifically derived issue, right? But the same thing is true with racial injustice. We have to evaluate the statistical data. And if the data does not support the narrative, we need to abandon the narrative. So that's what we're going to discuss in our next score discussion. We're going to evaluate the evidence, and I don't really know what the truth is yet because I haven't done the research, but I will have the research done by the time that we have this discussion. We're going to evaluate the evidence, and we're going to determine whether or not it supports the narrative. And you may have to abandon the narrative that you believe, again, observe, to be evidential. And that's growth. That's like a scientific mentality. I did this before because I'm stupid, and I'm not going to do it again because, again, it was like a tire fire. One of our score discussion topics was about the legality of abortion, whether or not abortion was a health care issue, or whether or not it was a human rights issue. And that went about exactly the way that you thought it would go. If you're imagining in your mind the awkwardness of that conversation, just go ahead and multiply that and then call it a day. But one of the benefits to come out of this train wreck of a discussion that we had, sometimes painful conversations need to be had. Over the course of the day, I had two people. One person was a very, very, very pro-choice person going into this discussion who came with a lot of evidentiary data, made some very, very, very solid points, and stayed after class and told me, Coach, I don't know what to do because now I'm having an existential crisis. And I said, yay, congratulations. And they're like, I came in prepared to defend my stance on this, and now I'm way more confused than I was. And it's worth noting that student did not change their opinion necessarily, but they at least recognized the complexity of the issue. That's the goal. I had another student in a different class period who was very, very, very staunchly pro-life and had the same comment after the class was over. I'm very conflicted and confused now because I've heard things that I had never considered. And that, ladies and gentlemen, is the point of Socratic discussion. You have to be willing to set your biases aside Consider things that you had never considered before and evaluate whether or not the evidence supports the narrative. And if it doesn't, you need to abandon the narrative. Because we have here's two vocab words I'm going to teach you. One is hindsight bias. Hindsight bias is this human bias where we tend to find things not surprising after they've happened. And that's probably not that shocking, but let me give you an example about why this matters. A lot of so-called experts come out in murder trials, serial rape trials, mass shootings, and they go on the stand and they pinpoint all of the warning signs and red flags that led up to this act. And they say, here are the things that should have been caught by the school system to keep this person from shooting up the school. That's hindsight bias. Because in reality, Mr. Guru Man, if you were so good at identifying red flags for school shooters, then what? What's the second half of that statement? What am I about to say? Say it. Why is it that we're not predicting them before they happen? It's hindsight bias. It's easy to see all of the causes after we have the event, right? Oh, I'm not surprised by that because of A, B, and C. I knew she was a trifling cheater the whole time. Interesting. After the fact. That's hindsight bias. But here's another one. This one's a little bit more applicable because it has to do with politics. This one is called confirmation bias. Confirmation bias is kind of this virus or plague that we have in social media. It's this idea that we create or we grab onto a narrative because it feels right, and we only stick to the evidence that confirms what we believe is true. Not that anyone would ever do that. We all do it. I do it too. We find evidence that's not false. We don't make up statistics, but we only go with evidence that confirms what we already believe to be true. In other words, we're only looking to support our narrative. And it's a really difficult thing for you to sit in the lunchroom and listen to your idiot friend rail about something that they don't know about, and you're like, listen, all of that, what you're talking about, is not empirical evidence. The data does not support the narrative that you're telling me right now. And it doesn't mean that you hate humans. It doesn't mean that you hate non-white people. It doesn't mean that you hate babies. It means that you want the data to support the narrative before you're going to support it, right? It's the difference between not guilty and innocent, right? In America, you are presumed innocent, and the burden of proof is on the accuser. They have to prove that you're guilty. You don't have to prove that you're innocent. They have to prove without a shadow of a doubt that you're guilty. And sometimes there's not enough evidence to convict you. It doesn't mean you're innocent. It means that you're not guilty based on the evidence that they have, right? And that's an important distinguishment to make. Sometimes you need to hold your judgment on something before you find out the data. And we're bad about this because, again, we're emotionally triggered. I wasn't very scientific when all of these riots started. I emotionally was triggered by the things that happened. I was heartbroken, and I jumped behind a cause which seemed noble and logical, and I have since abandoned that cause because the empirical data does not support the narrative that's being sold. And that's just the difference between logic and emotions, right? So here's the second phrase that I'm going to teach you, and it's a simple one. You've heard it a lot. Facts over feelings. Facts over feelings. Facts over feelings. You might have heard other teachers say things like, facts don't care about your feelings, right? We talk about biology and biological changes a lot in here, and it's important to note that biology doesn't care about what you think about it. Your interpretation of your human biology means absolutely nothing. It means nothing, the way you feel about your biology, because your biology is what it is. Homeostasis is what it is. The hypothalamus is what it is. The pineal gland, your genetics, they are what they are. That doesn't mean it's not a complex issue. Don't get me wrong. Don't get emotionally triggered. That's my point. You have to scientifically, empirically look to find the answer to these questions. So now let's segue into how that is done. How do scientists, psychologists study the theories that they have? Okay, well, there's a lot of different ways. The first thing, these are all vocab words. You don't need to feel the need to define them just yet, but I'm going to explain them to you. The first and the most, let's say the most ideal way to do any psychological research is a lab experiment. Experimentation is the most scientifically valid way to come up with a conclusion, right? So experimentation is very simple. We control for every variable. We do this in a controlled setting, right? So something simple like, what is the best study method for you to do well on a test? Well, on the first test, you studied like you normally do and you got a C, and you weren't happy with that. So now you're going to experiment. You're going to try studying over the course of a few nights instead of 2 hours the night before. And you're going to see if that changes your results. If it doesn't change your results, you're going to try something else. Those are different trials. Replication. So let's say, for instance, you took your test the first time and you weren't happy with your results. Well, now you're going to test a different theory. You're going to do a different trial. You're going to take a different process, a different approach, and see if your results are better. That's experimentation. You can eliminate all the other possible confounding variables and come up with an exact cause and effect. That's the benefit of an experiment. We can isolate cause and effect. 100% of the time when I light this piece of paper on fire, it burns. It's not a correlation, it's a cause. The fire burned the paper, right? If your dad is trying to figure out why the grass keeps burning up in the sun and he's scratching his head, he's going to do some experimentation. What if I water it for longer and it burns up again? Okay, that trial didn't work. What if I change the radius of my sprinkler spray? Add more minutes, more days. Okay, that didn't work. Maybe there's bugs that are eating the roots of my grass. And your dad goes out there and throws down insecticide. And that works. Okay, now we have identified the cause and we've come up with a solution. That's experimentation. That's the way that most scientists are going to try to conduct their research. But it's not always possible to do a lab experiment. Sometimes you have to do a field experiment, right? Which means you're not in a lab setting. So you go to the mall and you pretend to pick a fight with your friend who's in on the study just to see what people do. Well, that's a field experiment because it's not being conducted in a lab. It's not being conducted under controlled conditions. There are outside factors that you cannot eliminate. It's a field experiment. It's still an experiment though. So here's some buzzwords that you need to know. You're going to study these, obviously, for your vocab quiz. A theory and a hypothesis are two different things. Let me teach you the word to separate them. A hypothesis is testable. It's testable. A theory is like, I wonder if this teacher treats male students and female students differently. That's a theory, right? A testable hypothesis is, how are we going to find out the answer to this question? It has to be measurable. It has to be something where we can conduct an experiment and we can come to a conclusion based on the results. So maybe if you think one of your teachers is biased towards, say, male students, and here's what you do. You decide to set up a hypothesis. If people are caught cheating, the teacher is going to treat the male student differently than the female student. That's a hypothesis. It's testable. And so now you set up the scenario where you pretend to cheat. Now this is risky. This is the problem with experimentation. You're taking some risk here because you could get in trouble. You could damage your grade, right? Try that one when you get caught cheating. No. This is all an experiment. It's going to be a hard sell, right? So let's just say hypothetically you decided to do that for whatever reason, and you decide to get caught cheating. You and your friend who's a male student, you're a female student. You both have the same rapport with the teacher. It's not clear who's responsible for the cheating, so you both should get zeros. Is the teacher going to show some bias? That's an experiment. You're setting up an experimental design. You're testing your hypothesis. You're evaluating the results. You're coming up with a conclusion. Let me teach you another phrase. This is the next phrase. The first one, observation is not evidence. Facts over feelings. Here's another phrase. How do I want to state this? Here we go. A failed experiment is still a finding. A failed experiment is still findings. That's a good way to put it. A failed experiment is still findings. And here's what I mean by that. At the end of the year, you're going to have to do your research project, which is either going to be a correlational study or an experiment. And you have the whole semester to do it, which means you're going to do it at the last minute and have a panic attack. And it's worth a lot. It's worth a ton. So don't do that, but you're going to, because that's just who you are as a person. So you're going to do this experiment, and you're going to find out, some people find out very quickly that their hypothesis is completely wrong. That the results of their study do not match up. And they start to panic. And they send me messages and they say, Coach, my theory is not right. Am I going to fail? No. Because if we only researched the things that we knew were true, it would be nothing more than confirmation bias. So I'm going to say it again. A failed experiment is still scientific findings. Maybe you're happy to find out that your teacher, in fact, doesn't have a bias towards male students. That's still a conclusion. Maybe you find out that there isn't implicit laws written in America that unjustly prevent non-white people from being successful. I hope not. We'll do some research and find out. But it's still findings. So even if your theory is wrong, we still learned something. You still have to do the experiment. A failed experiment is still findings, right? So you have a theory, you turn that into a testable hypothesis, and then you gather data and you come to a conclusion based on that. Let me teach you something about a hypothesis. A hypothesis equals an if, comma, then statement. If you want to put that in quotes. An if-then statement. A hypothesis is always measurable as two parts. It has two variables. One that we're changing and the resulting one. Now I'll give you more details on that in a minute. But if you want to write the phrase if, comma, then, that's a hypothesis in psychology. Or sometimes it's like people who will blank, right? So if, then. Replication. Replicate is a buzzword that you definitely need to know. What happens if you conduct an experiment with your peer group at Gulf Breeze High School and you find out that 100% of the people in your study, cheated on a test when they had the opportunity? We still can't apply that to the entire population of America because Gulf Breeze High School is not representative of the entire population of America. Even if our demographics were representative, your ages are not. So if we want this to be true about everybody, another scientist with a different population is going to have to replicate your study. Or even you are going to have to repeat the study over multiple trials with different groups. We're trying to eliminate cause and effect, right? So replication is an important word. You've seen this going back to like 9th grade biology. It is the scientific method. We have a theory, we make it a testable hypothesis, we set up an experiment, we evaluate the data, we compare the experiment group to the control group, and we come to a conclusion. Sometimes our conclusion is not very helpful. Well, that's interesting. I did not expect that. All of the girls cheated, but the boys didn't. Which we know is probably not logical. Well, so sometimes your conclusion leads to an entirely different theory. Well, what if high-achieving girls are more likely to cheat than lower-achieving girls? And now we got to do a new experiment and find out, right? So sometimes your conclusions lead to more theories. So, other ways. We started with the experiment because that's the most ideal way to come up with a finding. But what if an experiment is not possible? Okay? So, you can write this phrase. When it's not possible to do an experiment, researchers have to. Right? When it's not possible to do an experiment, researchers have to. And there's other ways that they conduct research. So for instance, let's say that there's a person that goes to a certain university and their professor finds out that they have a photographic memory. Okay, that's something worth studying. So the professor finds out, I have a student with a photographic memory. Well, we can't experiment. We can't create people with photographic memories in a lab, but we have one. So that professor is going to conduct what we refer to as a case study. Okay, here's what I want you to write about case studies. Case studies are conducted with atypical or unique cases. Atypical or unique cases. And again, if we could experiment in a lab, we would do an experiment. Right? So let's say, for instance, we have two twins. Right? One of them has a photographic memory, the other one does not. Well, if we had the technology to find identical twins as babies that just came into this world, we steal them from their parents, separate them at birth, raise them in two different lab-controlled environments, we would have a lot of findings. But there's massive amounts of ethical problems with that. So it's not always possible to do an experiment, but sometimes it's possible, the technology exists, but it's not ethical to do an experiment. So we conduct other types of experimental research when it's not possible to do an experiment. I'm sorry, we conduct other types of research when it's not possible to do an experiment. So one way is a case study. Let me tell you some of the things that people confuse about case studies. This will save you some test questions. For some reason, the people infer, it's implied in the way that it's phrased in the book, that a case study is always one researcher and one participant. A case study does not have to be one-on-one. It can be a small group of people. What if you're not studying a person with a photographic memory? What if you're studying people with traumatic brain injuries? And you go to a brain center and you find 10 cases of the same traumatic brain injury. Well, it's a case study because you can't experiment to create this brain injury, but you still want to know. You still want to know details about these people. So you study them in depth in a small group setting. That's a case study. It's atypical or it's unethical to replicate, but you still want to know. The advantages are you get a lot of information about a specific case. But the disadvantage is that it might be so rare and so unique that you can't really tell whether or not it will apply to everybody. A good example of a case study is a guy named Phineas Gage. During the Industrial Revolution, obviously the railroad boom was happening. Well, there was a railroad worker named Phineas Gage whose job it was to take this metal spike and chip holes into granite, into rock base, so they could put gunpowder and blow it up so they could build railroads. In one such case, he drives this iron spike into a hole in the rock that already had gunpowder in it. So chipping the rock caused a spark, and it fired the iron rod through the front of his skull and out of the top of his head. He didn't die. It took him a couple weeks to recover, but he fought his infection, had a massive hole in his skull. But he had some interesting effects. You'll read about this in the chapter. He had a drastic personality change. And brain science was very new at that time. And the doctors didn't really know what to make of it. In fact, he was so unbearable of a human being, his wife left him. He lost custody of his kids. He was fired from every job. He became ornery and angry. He became a drunk. He cussed too much, even though he was a devout Baptist before that who never cursed. His personality drastically changed. And other than losing vision in the eye that was destroyed by the iron rod, he had no other cognitive function that was different. He had no intelligence change. He had no memory loss. He just had a drastically different personality change. So there was a theory from that. And case studies that were done. I wonder if that's the part of the brain which was destroyed by the iron rod in Phineas Gage's skull that houses the human personality. And now we know that it is. That's a case study. Because you're not going to go in a lab and replicate the damage to a human brain that Phineas Gage suffered. Well, we have the technology. They can drill into your skull. Ooh, that's exciting. They can drill into your skull and take a laser and cut out a whole bunch of neural tissue. And they could simulate Phineas Gage's injury. But they're not going to do that. So a case study is used when you can experiment, and it gives you lots of data. But the downside of that is Phineas Gage is an independent person. We can't necessarily apply what happened to him to every single person who had the same injury. It's not experimental, so we can't get a cause and effect relationship. What if it's not a case study? What if it's a survey? What happens when we need lots of statistical data and it's not ethical to replicate this in a lab? Well, you might ask people survey questions. And there's benefits to survey questions because you can get lots of information to plot all at once. They're cheap. It's easy to compile data. It takes a few minutes to fill out surveys, but there's some downsides. People don't tell the truth on surveys, even when they're anonymous. Even if they do, you have no way to prove that they did tell the truth because you're not controlling it in a lab. The other thing is the wording effect. When you look at things like, there were a lot of surveys that were evaluated from political polls. So these psychologists and their teams evaluated the phrasing of certain survey questions. And for instance, in some surveys they use the word rape. In other surveys they use the word assault. That's going to change the way that you're emotionally triggered when you read the question. That's going to skew the results. Right? Even the idea when we talk about abortion of pro-life versus pro-choice. Those two things are not opposites. You don't say, I'm pro-choice and I'm pro-death. Sign me up. I'm against personal choice. It's a phrasing effect. It's a wording effect, right? So surveys have their downsides also. And then another way that psychologists conduct research when it's not experimental is something that's known as a naturalistic observation. Let me give you a hint that's going to save you some heartache on a test. How do I know it's naturalistic observation and not a case study, coach? Okay, here's a surefire way to tell that it's naturalistic observation. It's a naturalistic observation when the test subjects are unaware that they're being evaluated. When they don't know that they're being evaluated. That makes it naturalistic. So if you want to see if your son's a bully, you don't tell him you're going to follow him around at school. You go and watch him at the bus stop. Or you go and ask his teachers who watch him. You want all of the naturalistic things about the normal environment so they'll act the way they normally do. And this could be animals or people. Right? Little kids, a great example of naturalistic observation. If you want to see if boys are more aggressive than girls with the same toys, you don't tell them you're testing aggressiveness. You tell them, hey, we want to see if you know how to use all of these toys. And you get to play with them for 20 minutes. Go ahead. And you're evaluating how they act. It's naturalistic observation because they don't know they're being evaluated. That's the telltale sign in a test question that it's a naturalistic observation and not a case study. So somebody asked in another class period, which was a good question, have you guys heard of the show, like, What Would You Do? That's an example of naturalistic observation. You go into a restaurant and throw your food around to see what the people around you would do. That's a naturalistic observation, right? And obviously there's some pros and some cons for that. But the people you're observing their behavior and they don't know they're being tested. In fact, if you really want to observe people's true behavior, you probably shouldn't tell them that you're going to observe their behavior because you get what's called the Hawthorne Effect. And the Hawthorne Effect is when people know that they're being tested, they tend to act certain ways. Like if you tell little kids, the principal's going to come in and see if you get to move on to third grade, right? They start acting, they straighten up. So what little teachers do to little kids is they lie to them. It's good teaching, right? You lie to them and say, you're not going to get to go to second grade. It's just mean to think about, right? The principal's going to come in and watch, right? It's called the Hawthorne Effect. If you know that your actions are being watched, you're going to perform differently. The best example of the Hawthorne Effect I could give you is when I coached. When an athlete knew that they were being evaluated by a college recruiter, whoa, they were like the most all-American practice player in the history of sports. All of a sudden, these leadership qualities came out. They're getting on to their teammates. Excuse me. They're finishing every rep. And we're like, who's this guy? It's the Hawthorne Effect. They know they're being evaluated, and so they kind of, even if they don't realize they're doing it, right? All right, so I put this in big, bold. You don't have to write it down, but this is a very important distinguishment. This is something that gets mistaken a lot on tests. The difference between an experiment, which we've talked about a little bit, and a correlational study. So here's what you should do. Create two columns. Experiment on one side, correlation study on the other. We're going to do a little contrast situation, if you will. Let's start with an experiment. Obviously, we already know it's the most ideal because we can isolate cause and effect. We already know that. If it is a causal, let me say this. If the effect is causal, it has to be an experiment. Sometimes people misread that word on tests as the word casual. Causal, C-A-U-S-A-L. If it's causal, it's because we conducted it in a lab against a control group and got a 100% ratio. Causal. Cause and effect. Again, I water the grass and it grows. It's cause and effect. It's not prediction. It's not correlation. Well, 92% of the time when I water the grass, it grows. It's causal. It is a cause and effect relationship. But let's get into the details here. The independent variable, or the IV, that's a vocab word, but here's what you need to know. The key word here is the manipulation. The independent variable is the if part of the hypothesis. It's what we're changing, right? If I study, then I will get a better grade. So the independent variable is what's being manipulated, what's being changed. That's what we're adding or taking away. Now, what if it's a clinical trial for a drug? Let's say that you have some kind of like heart condition, and so you get approved for this clinical trial. Well, you're either in the experiment group, which is getting this new drug, or you're in the control group, which is getting a placebo. So they have to compare the drug against the placebo to see if it works better or worse or the same. If the placebo works just as well as the drug, then the drug doesn't work, right? So you have to have comparative data. C for control, C for comparative. Your control group is the group that you're comparing the experiment group to. So the independent variable, or IV, you can always abbreviate it IV, even on an FRQ. IV is what we are changing in order to get a result. So in an if, comma, then hypothesis, the if is the independent variable, right? If we get more sleep, then we will get more answers right. The if part is what we're changing, the action that's being taken. After the comma, you have the then part of the hypothesis. This one we're not going to manipulate. You can't manipulate the result. This part is the dependent variable. Now, if you look at the statement backwards, it makes more sense. I don't want to confuse anybody. You say, if I study, then I will get a better grade. Well, when you look at that backwards, whether or not I get a better grade is dependent upon what? Whether or not I study. So when you look at a hypothesis backwards, it makes more sense. The dependent variable is called a dependent variable because, again, not to be redundant, it's dependent upon whatever it is that we changed. If I study for 4 hours and get the same grade, we can conclude that studying either doesn't work or I'm not doing it right. So now you pick another trial. You try to study a different way and see if that changes your results. It's an experiment, right? So we have independent variables that we manipulate. The dependent variable is the result, the then, right? If I add Miracle Grow to my tomatoes, then they will grow, right? The if part, the independent variable, that's what we're adding, right? The then part is the dependent variable, whether or not they grow. And we have to have a control group. Again, C for control, C for comparison. So if I want to see if Miracle Grow makes my tomatoes grow more, I have to have some other tomatoes that I don't give Miracle Grow to so I can see, right? Maybe we just got more rain this month. It's called a confounding variable. We have to isolate cause by eliminating all the other possible causes. All right, a lot of vocab. You don't have to write the definitions here, but I'm going to walk you through this. Variables we talked about. Variables are operationally defined. Variables are listed as X and Y. There's two axes, right? So one of the things I want you to write under your experiment column is bar graph. An experiment is always plotted as a bar graph. You have an X and a Y axis. Bar graph. The X-axis is the independent variable. The IV is always on the X-axis. The Y-axis, the vertical axis, is the dependent variable. So you have two bars on the bar graph. The tomatoes with the Miracle Grow and the tomatoes without the Miracle Grow. And then you measure the bar. If the tomatoes with the Miracle Grow grew 2 more inches, we can conclude that the Miracle Grow works. Dependent variable is the Y-axis. The independent variable is the X-axis on a bar graph. In your correlational column, it's not a bar graph for a correlational study. It's what's called a scatter plot. A scatter plot. Anybody taking statistics or have taken statistics in here? So you've heard of a scatter plot. It's one quadrant, right, on a graph. So bar graph for experiment, scatter plot for a correlational study. So we have variables. We have the independent variable we talked about, the dependent variable, which is the result. We have the experiment group and the control group. All right, now let's talk about some of the issues. In an experiment, you have to be able to control the setting. In other words, the two groups have to be put to the same conditions. If we want to test to see who are better drivers, 16-year-olds or 18-year-olds, we can't put the 16-year-olds on a simulator and the 18-year-olds outside on the pavement. There's too many confounding variables. So you have to have the same experimental conditions for both, right? So a good example of this was that one of the better projects that was done 2 years ago was whether or not people were led to believe that they could hold their breath longer based on the average time, right? And so they told people at the beach the average person can hold their breath for whatever, 3 minutes. People held their breath for longer just because they thought, right? So, but the idea is every time you replicate that, you have to put it to the same conditions. Well, sometimes people were in a pool, and we told them they could hold their breath for 2 minutes, and they did. Other people they were in a pool, and we told them that the average time for holding your breath was 45 seconds. So they have to be set to the same conditions, right? Otherwise, there's other possible explanations. So experimental control matters, right? And the experimental setup matters. Expectancy, again, bias. even if you don't realize you have a bias, as a researcher, you might have a bias. So if you're giving out placebos and pills to everybody, and like one of them is going to make you hyperactive, and you know that all the odd number pills are the hyperactive pills and the even number pills are the placebos, you might be like looking around the room for implicit bias, right? Or you might have some implicit bias. So the way to avoid bias is called a blind study, right? Blind study. There's single blind and double blind. A single blind study is when the participants don't know which one is the real thing. They don't know if they're in the experiment group or if they're in the control group. Again, let's say that you have some heart issue and you go to a clinical trial. You don't know if you're getting the actual medication or if you're getting a placebo that looks like the actual medication, right? That's a single blind study. A double blind study would be the person actually handing you the pills doesn't know which one you're getting. Now think about this logically. A lot of people get this confused. Someone somewhere has to know which one is the real pill. Otherwise, you can't conclude your results. So it's just the people in the room that are blind, right? Somebody behind a screen or behind a one-way mirror, they probably know the odd numbers or the drug and the even. Let's say this. Let's say you wanted to do a taste test of like Pepsi versus Coke. Like smart water versus tap water. Well, you're going to give two cups, cup A and cup B. Somebody has to know which one has got spring water in it. But it doesn't have to be the person who's giving you the cups. Right? Somebody behind a closed door could fill them in cup A or cup B, and someone else could take them in here. Here you go. Which one is it? Cup A? Okay, we'll write that down. And then you analyze the results. So a double-blind study, neither the participants nor the person conducting the trial, right? The researcher nor the participant. The placebo effect we talked about. The placebo effect is a big deal. If you think something is going to happen, it might cause the results. And you might say, okay, well, this is a scientifically invalid protocol. Not really. Here's an interesting statistic for you. When they were doing a clinical trial for Rogaine is a hair loss foam that you can put in your hair. So they're doing the clinical trial for Rogaine. They have the active chemical in the foam. They give it to people in the clinical trial. They have a control group, which is a placebo, and it's foam that's identical in an identical can, but it doesn't have the active ingredient in it. It doesn't have the chemical. This is an interesting statistic. 23% of the people who had a placebo grew more hair. Now I want you to unpack that for a second in your mind. Believed that they were using a hair loss chemical, so the biology of the follicles on their scalp began to grow hair again. That's kind of crazy to think about. So that means that if you believe something enough, you can actually biologically change. That's crazy. There have been cancer studies that are very experimental for stage 4 patients who have no other options, using the placebo effect to shrink tumors. It's crazy. Surgeons, they conducted this massive study with the placebo effect where they told people, listen, this is an experiment. There's a chance that we're not actually going to surgically do anything to you. Do you agree? Yes. So they take these people in for like a knee scope. They make an incision and open their knee up and sew it back together and wait for them to wake up. This is intense, right? People get a scar on their knee. They tell them, we've conducted this knee scope, right? Massive amounts of people believe that their pain is now gone just from believing there was surgery. All right, so we're going to get into how to plot this stuff tomorrow.